Identifying all singular points and points of discontinuity of the given piecewise function f of x equals x plus 2 if x is on the left-hand side of 0. On the left-hand side of 0, the piece or the formula is y equals x plus 2. 2x plus 2 if x is between 0 and 2, including 0. And so the middle piece is 2x plus 2 and x squared plus 2 if x is greater than or equal to 0. It helps if we do this so that we know what the breakpoints are. To identify the singular points and points of discontinuity, we first evaluate the function at each of the breakpoints. We see that f of 0, the first breakpoint, the formula that is defined at x equals 0 is 2x plus 2 with the equal sign here. And so we would use the formula 2x plus 2 to evaluate f of 0. 2 times 0 plus 2, which is 2. Another breakpoint is x equal 2. With x equal 2, the formula that is defined at x equal 2 is x squared plus 2. And so we have 2 squared plus 2, which is 4 plus 2, or 6. F of 0 equals 2 and f of 2 equals 6. We then determine the limit at each of these breakpoints. The limit at x goes to 0 from the left-hand side of f of x is the limit at x goes to 0 from the left-hand side. On the left-hand side, we would need to use the formula x plus 2. At x goes to 0, x goes to 0. So this is 0 plus 2, or 2. Next, the limit at x goes to 0 from the right-hand side of f of x is the limit at x goes to 0 on the right-hand side of 0, immediately on the right-hand side of 0, the formula that we would need to use is 2x plus 2. As x goes to 0, 2 times 0 would go to 0. So we end up with 0 plus 2, which is 2. Since the limits at x goes to 0 of f of x from the left and the right-hand side are equal, then the limit at x goes to 0 of f of x is 2. And we see that this limit equals the value of the function at 0 itself, which is also 2. Then there is no singular points, or there is no points of discontinuity. This is the precise definition of continuity of the function at x equals 0. We summarize that f is continued at x equals 0. There is another breakpoint that we will still need to determine whether it is a singular point or points of discontinuity, and that is at x equals 2. The limit at x goes to 2 on the left-hand side of f of x, on the left-hand side of 2, immediately on the left-hand side of 2, it helps, again, if we do this so that we clearly see that on the left-hand side of 2, the formula that we will need to use is 2x plus 2. At x goes to 2, 2 times 2 is 4, so we have 4 plus 2, or 6. The right-hand side of 2, at x goes to 2 on the right-hand side, the limit of f of x is on the right-hand side of 2. The formula that we will need to use is x squared plus 2. And at x goes to 2, x squared goes to 4. And so we would have 4 plus 2, or 6. The limit at x goes to 2 from both sides of the function is therefore 6. And this equal to the value of the function at x equals 2. We computed earlier, f of 2 is 6. And so we also say that f is continued at x equals 2. Now, x plus 2 is a continuous function on its domain. 2x plus 2 is continuous because both of these are linear functions. X squared plus 2 is a quadratic function, so it is continuous on its domain. And so the only possible point of discontinuity and singular points are at the breakpoints, but we check that at those two breakpoints the function is continuous. And so in this case, there is no singular point, or there's no point of discontinuity. In this case, we say that the function, although piecewise, it is continuous everywhere.